Okay, here is our last page of the Chapter 14 review, which is page 879. Let's go ahead and start with 19. It says the state of Nevada is almost the shape of a quadrilateral. Now, in your book, I'm sure you can see it. It's kind of cut off in my recording here, but in your book, you can see the full shape of the state. Complete the attributes or the characteristics of the outline of the state of Nevada. So it says there is blank set of parallel opposite sides. So let's look at it. How many pairs of opposite sides are there? Well, if I look here and here, these are parallel. But if I look to the top and the bottom, they are not. So this figure has only one set of parallel sides. It's actually the left and the right are parallel. The top and the bottom are not. It says opposite sides are not equal in length. Opposite angles are not the same size. But there appears to be, how many right angles do you see here? So you have to look back up at the map of the state of Nevada and find how many perfect corners can you find. Well, I see one up here. One. I see one up here. No, this isn't a perfect corner. That's too big. And this one down here, which isn't showing on my recording, but you can see it. It's not a perfect corner. So it looks like we only have one perfect corner here and one perfect corner here for two right angles. Okay, number 20 is going to be one of these guess and checks where we're going to start by guessing a couple of numbers. We're going to figure it out, see what the answer says, and if we're wrong, we're going to keep trying until we get the answer correct. So here it is. It says Karen is thinking of two numbers. Their difference is 9, so that means when I subtract the two together, I get a difference of 9, and their sum is 17. Sum meaning if I add them together, I will get 17. So what are the numbers? So let's just start. You might want to take a piece of paper, scratch paper, or work on the side of your math page, and let's just start adding a couple numbers together and subtracting them. I'm going to go ahead and start with 6. So if I start with 6, I need how much to get to 17? I need 11. So let me add together 6 plus 11. That gives me 17. So there's my sum of 17. But now I'm going to subtract them. I'm going to take 11 minus 6, and that gives me 5. So that's not right. The sum was correct, but the difference wasn't. All right, let's try another number. Let's try 5 this time. If I add 5 times plus something, 5 plus 12, that'll give me 17. So now I have to subtract 12 minus 5. And what do I get when I subtract 12 minus 5? I get 7. So the sum is correct, but the difference isn't right. All right, we tried 5 and 6. Let's go ahead and try 4. What would I add to 4 to get to 17? Something plus 4 will give me 17. It's 13. So if I add 4 plus 13, I get the sum of 17. Now I have to subtract. 13 minus 4, what's that? 13 minus 4. Take away 4 from 13. That does give me 9. So my sum of 4 plus 13 is 17. My difference of 13 minus 4 is 9. So the two numbers are 4 and 13. Okay, good. Let's go to the next one. Naomi cut out 2 figures from construction paper. One figure is rectangular. The shape of the second figure has all the attributes of a rectangular figure. In addition, it has 4 sides that are equal in length. Classify the shape of the second figure. So here we go. The shape of the second figure has all the attributes of a rectangle. In addition, it has all 4 sides that are equal in length. So some of the the attributes of a rectangle are the opposite lines are parallel, but in this case, they're all the same length. So think of a quadrilateral with parallel sides and all four sides the exact same length. What is that? That's a square. Good job, square. Okay, number 22. 4 students were asked to draw a parallelogram. Each drew a differently named figure, but each was correct. And how could this be? So if I drew a square, that would be a parallelogram. If I drew a rhombus, which is sort of a pushed over square, this right here looks like a rhombus. It's a square that's been kind of tilted over. Or if I drew a rectangle, that would be a parallelogram, which are, all three of those are different figures. So that's how it's possible. One student drew a square, one student drew a rhombus, which is that pushed over square, and another student drew a rectangle, and all are considered to be parallelograms. Do you remember we were doing those family trees, and from parallelogram we had a rectangle, we had a square, and then we had a rhombus. They're all related. They all share certain attributes, but they're different figures. So again, our answer here is square, rhombus, and rectangle. And each child drew something different. Okay, here's our last one. It says, identify the figure that is not a trapezoid. Now, a trapezoid is a figure that eventually, if I draw the lines, they're going to touch. The example was the Eiffel Tower. Right at the beginning of this chapter, showed you a picture of the Eiffel Tower, and there was a piece that was a trapezoid. So it looks like those are going to touch. Let's see if these will touch eventually. If I draw this one down and I draw this one, yep, that's going to be a trapezoid too. Let's try this one. I'm going to keep drawing a straight line to about here, and then draw a line to here. That's going to touch as well. So it looks like this one touches, this one touches, and this one touches. Will this one touch? If it doesn't, it's not a trapezoid. Go ahead and try it. Draw the line all the way here to here and here to here. No, those lines are never going to touch. Let's try this side. I drew it here, I drew it here. Those are never going to touch either. So this A is our answer because this is the one that is not a trapezoid. This is actually a rhombus. These lines are parallel. And remember, parallel lines are always the same distance apart and they're never going to touch. So our answer is A. Okay, that's it for the chapter review. There's actually a page 880, but we're not going to go ahead and do that this time. So you guys are all done with this math book. And you know what? Congratulations. You have learned so much in math this year. You learned how to multiply, you learned how to divide, you learned fractions, you learned all of this geometry work. So you guys have been great, and I'm so proud of the progress that you've made in math. Congratulations. Okay, talk to you later.